Okay, so in this video we're going to look at the inverse sine function. We're going to be looking at how we can restrict the domain and also the codomain of the sine function in order to make it invertible. And then we get an invertible function on that restricted domain and codomain. So we get invertibility at the cost of restricting the domain and codomain of the function. It's no longer a function from R to R. It's going to be a function from a restricted domain to a restricted codomain, which we'll see shortly. So as you can see, here we have a poorly drawn graph of the sine function. For one thing, it's kind of sort of shaky, but more importantly, it's not to scale. So just in case you were wondering, I made the ticks for 1 and -1, the upper and lower bounds of the function, at the first block up and the first block down on this grid paper, and then I put the pi over 2 tick marks 2 blocks over. Of course, pi over 2 is less than 2, so this thing is kind of stretched out a little bit, but nevertheless, you get the idea. I want to come up with an inverse function for this, right? I want to come up with this function, this arc sine function, and I want arc sine of x to be equal to x, and I also want sine of arc sine of x to be equal to x for every x in the domain of sine, and also for, in the second case, every x in the domain of arc sine. So that's what it means for this arc sine function to be the inverse of sine, with that they undo each other. But as we've seen in previous videos, in order to be invertible, a function has to be bijective. It has to be 1 to 1 and onto. And so for one thing, sine is not, if I have the sine function sine of x going from r to r, it is not onto. It is not surjective. Its domain is not all of r. Its range is not all of r. Its range is from -1 to 1, and it is definitely not injective either. In fact, it fails the vertical line test the horizontal line test rather, spectacularly, which means that if you invert it, the inverse will fail the vertical line test spectacularly. For every y value in between 1 and -1, there are going to be infinitely many points in R that could map to that y value. Right? It is horribly not 1 to 1. So what we're going to do is, first of all, it's pretty obvious that we have to restrict well, I want to do that in green. It's pretty obvious that we have to restrict the codomain to be the range, to coincide with the range. That's the first step in making this thing invertible, is because in order to make it onto, well, it's onto if and only if the range is the same as the codomain. So we're going to restrict the codomain to be the range, and that takes care of that. But not so obvious is how we're going to restrict the domain. We need to restrict the domain. We've taken care of the onto-ness. Now that has to do with the codomain. Now we need to restrict the domain in a way that makes it 1 to 1, so that it only sends to every y value in this restricted codomain. It sends exactly one x value to that point, not infinitely many. And so there are actually infinitely many possibilities, infinitely many choices for the restricted domain. But we're going to pick negative pi over 2 to pi over 2, because on this restricted domain, it's nice and 1 to 1, as you can see, right? It passes the horizontal line test everywhere, and also it does everything that it's going to do, right? It starts out at -1 and it goes up to 1 continuously. It takes on every value that it will ever take on, and so this is a great choice. This is a terrific choice. That also goes through the origin, right? It's very, very nice. It's in between 0 and 2 pi, and it goes through the origin. So we're going to get rid of the rest of this thing. So I'll cut it off there. Maybe I can do a little bit better job. There we go. I'll cut it off there and also there, and then delete the rest of these things. You and you go away. Okay. And now with this restricted domain, I get sine going from negative pi over 2 pi over 2 closed to, I should write this nicer, I'm sorry. Let me actually just write this out properly. Sine is going, instead of from r to r, now we have restricted sine of x to go from negative pi over 2 to negative 1, 1. There, that wasn't so bad. I was just being lazy. This, of course, means because arc sine is the inverse of sine, and the domain of the inverse is the range of the function, and the range of the inverse is the domain of the function. That means that arc sine of x, I'll do that over here, arc sine of x is going to go from, let me move this over so I have enough space and it's not too squished, it's going to go from negative 1, 1 to negative pi over 2, pi over 2. And in particular, we know that sine of pi over 2, negative pi over 2 here is negative 1, and sine of pi over 2 is 1. So this means that arc sine of negative 1 is going to be negative pi over 2, and sine of 1, or arc sine of 1 is going to be sine of pi over 2. And this is the key to graphing this. We have to be careful with, the next one up will be cosine inverse, or arc cos. And that one, the order is switched. It sends the left endpoint to the right endpoint rather than the left, and vice versa. So we have to be really careful with that one. But with this, it's not so bad to graph it. Although I still may be able to screw it up. We'll see about this.